Hello everybody, this is Dr. Christopher White, and in this video we're going to continue with our review of the lab exercise relative dating. So we've moved on to part B now, and this is going to focus on the stratigraphy of the Grand Canyon. So obviously we're going to be applying the principles of relative dating in order to answer several questions about what's going on with the Grand Canyon. Now, I've actually got the diagram itself, figure 4.8, slightly larger over here on the right. And you can see the diagram consists of several parts. So over here on the left, we actually have the stratigraphy of the Grand Canyon displayed as a schematic cross-section through the sequence. So you're going to notice that there are three main parts to the Grand Canyon. So we have the basement rocks, which are marked out by the Vishnu schist and the Zoroaster granite. Obviously, Vishnu schist is metamorphic, Zoroaster granite is igneous. Then you can see we have a sequence of stratified, layered, sedimentary rocks mostly, although there is a basalt layer in there as well. And you can see that this sequence of rocks has quite clearly been tilted. Then we have a sequence of horizontally bedded sedimentary rocks. You will also notice that there are two unconformities marked. The first one is called the first great unconformity, and it's marked out by this neon green. And then we have the second great unconformity, which is marked out in red. Also, on the right of the diagram, you can see we have a stratigraphic column for the Grand Canyon. I just want to make sure you take note of this part right here. This lists the periods which are represented by the rocks of the Grand Canyon. There are going to be some questions later on where you're going to be asked to identify, which periods are missing or present in the Grand Canyon. So making sure that you realize that this information is available in the stratigraphic column is going to make your life a lot easier when it comes to answering those questions. Okay, so we're going to move on and start with question 1. So the first thing is it's going to ask you, what is the oldest rock unit on display in figure 4.8? So if we look at figure 4.8, well, you got to think to yourself, which principles of relative dating are really going to be most helpful here? And typically when you have a big sequence of rocks like this, it's always best to start with the simplest solution, go with superposition. All right. Does superposition help you answer this question? So think about that, or think about, are there any other principles which are also going to aid me? So once you have worked out what the oldest rock unit is in figure 4.8, you're then going to answer question 2. And question 2 asks you, which two principles of relative dating did you use to identify the oldest layer? So once you've worked out what the oldest layer is, think about the principles that you employed to actually come to that conclusion. And please write your answers, principle 1 and principle 2. So question 3 is going to ask you, what is the youngest sedimentary layer in figure 4.8? Now, as discussed, on the diagram, we clearly have the basement rocks, which consist of a metamorphic rock, a schist, and an igneous rock, a granite. And there is also a single basalt layer as well. So those are the only non-sedimentary rocks in this sequence. Now, when you look at the diagram itself, you will see that some of the layers presented on the diagram have distinct sedimentary rock names as part of the name for that particular layer. So you have, for instance, a sandstone here, and you have the shale here. So these are actual rock names, so that tells you what that layer is made from. So the Hermit Shale is made of shale. Now, in the case of some of the other layers, for instance, like the Mankapai Formation, it doesn't give you a distinct rock name. And that simply tells you that this particular unit consists of 2 or more different types of sedimentary rock. So even though, as part of the name, no distinct sedimentary rock type is noted, even then, it does mean that anything that has the word formation after it is considered to be a sedimentary layer. Okay, so all of these layers here would be considered sedimentary. All of these layers here would be considered sedimentary, obviously with the exception of the basalt, while the basement rocks would be considered igneous and metamorphic. Okay, so work out what the youngest sedimentary layer is, and then for question 4, work out what the oldest sedimentary layer is. And then you're going to move on to question 5, and that's simply going to ask you, which two principles of relative dating did you use to identify the oldest sedimentary layer? And so once again, once you've identified the oldest sedimentary layer, think of the principles that you used to make the identification. So when it comes to questions like question 2 and question 5, if you find yourself getting a little bit uncertain about which principles you use to come to that conclusion, send me an email and I will try and guide you towards the correct answers. I'm not going to give you the answers, but I'm going to try and point you in the right direction. So for question 6, what is the youngest Precambrian sedimentary layer? The inclusion of the word Precambrian is very important here because it's helping to limit the portion of the Grand Canyon stratigraphy that you're actually looking at. So if we come over here to our stratigraphic column, you will notice that everything above the second great unconformity is Paleozoic or Mesozoic in age. So it's not Precambrian. So we're going to ignore all of those rocks. You will then notice that between the second great unconformity and the first great unconformity, you have a sequence of sedimentary layers which are Proterozoic in age. So these are clearly Precambrian rocks. So this is where your focus will be in order to answer question 6. Okay, on to question 7. So what type of unconformity is the first great unconformity? So the first great unconformity is running along here and it's marked out by this neon green line. So you'll notice the first great unconformity obviously moves along the base of the Bass limestone, which is a sedimentary rock, and it marks the point where the Bass limestone is in contact with the basement rocks, which, as we've previously mentioned, consists of both the Vishnu schist, which is metamorphic, and Zoroaster granite, which is igneous. So go and look at the 4 different types of unconformity, and based on what I've just described, work out which type of unconformity the first great unconformity would be. On to question 8. So describe how the second great unconformity, which is this red line here, changes as it progresses from the western left-hand side of figure 4.8 to the eastern right-hand side. So as we move across, we can actually see that the second great unconformity is not just one type of unconformity. It actually consists of 2 different types. So you're going to have to say, right, for instance, on the western side, what type of unconformity do I have? And as I move to the east, what type of unconformity does it change into? On to question 9. So for question 9, which layers in the Grand Canyon stratigraphy constitute the Pennsylvanian? Okay, so how are you going to work that out? Once again, you're going to come over here to our stratigraphic column and you are going to locate the Pennsylvanian layers, and here they are. All right, so you can see we have these 4 layers here, but I also want to point out this boundary right here. It is not a horizontal line. That should give you some idea about which of these layers are Pennsylvanian in age. And so once you've worked out the layers, come over here to the diagram itself and work out which layers these units correspond to, and then write down their names. Okay, question 10. The bedded Precambrian rocks of the Grand Canyon have clearly been tilted. So we're talking about this unit of rocks down here, and you can quite clearly see they're not horizontal anymore. So you need to use the rock units in figure 4.8 to define the timing of this tilting. So when we look at figure 4.8, we are going to use rocks which are older and younger than the tilting to work out when that tilting occurred, or at least define the range in which that tilting occurred. So you're going to look at this unit of Precambrian rocks. You're going to say, right, which rocks were present before this tilting occurred? And then you're going to look at the sequence of rocks and you're going to say which rocks were present after this tilting occurred. And that's going to help you to define the range of time within which this tilting of the Precambrian sedimentary layers of the Grand Canyon occurred. So you're simply going to note the tilting occurred after layer, and you're going to name your layer of rock. And then you're going to say the tilting finished before layer, and then you're going to say name your layer of rock. So on to question 11. That simply asks you which Paleozoic periods are missing from the Grand Canyon stratigraphy. So once again, come over here. Now, please note it quite clearly states Paleozoic periods. All right. Doesn't mention anything about the Precambrian, doesn't mention the Mesozoic, doesn't mention the Cenozoic. Okay, so when you come over here to your stratigraphic column, your periods are listed right there. If some of them are missing, there's your answer for question 11. On to question 12. So the Temple Butte Formation, so Temple Butte Formation is here, okay? It's this purple blue color, and you can see it forms these distinctive kind of semicircular shapes within the Mave limestone. So the Temple Butte Formation occurs as bodies of limestone which have been incised. That means cut into the Mave limestone. The fact that, I've used the word incise should be a very strong hint that clearly some kind of erosional process has occurred. In cross-section, so if you take a slice through the sequence of rocks, you will see that the Temple Butte Formation occurs as semicircular lenses. And you can see them here. There's one there, one there, one there. Now, if you look, on the other hand, from the top down, so in plan view, in map view, what you would notice is that these bodies of limestone that represent the Temple Butte limestone actually form long, linear, snaking structures. And so the question asks you to try and work out what was the most likely process that led to the formation of the Temple Butte limestone based on its morphology. So would sandstones produce the shapes which are described above? Or would a river system produce the shapes which are described above? Or would a normal fault produce the shapes which are described above? If you find it difficult to answer this question, and you've thought about it and you can't work out what the answer is, email me. I'll try and guide you in the right direction. So on to question 13. Which environment is most likely to produce limestones? So think about modern environments where limestones tend to be produced in large quantities. So classic examples would be somewhere like the Florida Keys would be a good example. The Caribbean might be a good example. There are several examples, for instance, off the eastern coast of Australia. There are lots of examples in the Indian Ocean, for instance. So that's going to give you some kind of idea of where ancient limestones were produced. So we are using the principle of uniformitarianism. We're looking at modern examples and saying, well, what are the conditions under which modern limestones are being produced? And we are applying those to ancient limestones. And then finally, on to question 14. So using your answers to questions 11 and 12, and also to a certain degree 13, we're going to look at the sequence of events that must have occurred to produce the Mave limestone, the incised structures and that cut through it, and the deposition of the Temple Butte limestone. So number one, think about the conditions, think about what must have happened in order to form the Mave limestone. Once you form that limestone, then you need to think about, well, what happened to form the bodies within which the Temple Butte limestone was deposited. Okay, so what formed these incised shapes into which the Temple Butte Formation was deposited? And then finally, what happened in order to actually form the Temple Butte Formation? What conditions had to be met in order to make that happen? And so once you've written those out, hopefully you'll be able to explain the stages that were required to form the Mave limestone, the incised structures, and then finally the deposition of the Temple Butte limestone. So part 2 is on the whole relatively straightforward. If you find yourself having difficulties, number 1, go and look at the lecture. It contains diagrams of each of the principles of relative dating. Those could be helpful if you are getting stuck. If you still can't work out what the correct answer is, please email me. All right, I will get back to you as soon as I can. All right, thank you for watching and have a good day.